My name is Freek Post. I'm a Dutch guy. Usually my name is pronounced Freek here in Spain, so no worries, I'm used to that. I'm a blockchain developer in London. I used to live for a while in Barcelona, but don't ask me about speaking Spanish, because I'm still learning that. I worked on a bunch of open source and closed source blockchain projects since 2016. Two of the bigger ones are Ethereum, which is like decentralized insurance, and Maker. These are the guys behind the DAI, the stable coin. So what I want to do today is give you a quick overview of what blockchain is, the same with Ethereum, then go over to what you can do with Truffle and how it can really help you with blockchain development, and then finally show you a short demo of what you can do when you set up Truffle. Let's see, so blockchain. So what is it? It's basically a decentralized distributed ledger that keeps a permanent tamper-proof record of all previous transactions. Now, in simple terms, it basically means everybody has the same book, the same logbook of what happens on the network. And the advantage of that is that you don't need a central party to overview and provide trust to the network. To give you an example, on the left side you see the traditional way banking is done. You have a central party, which is the central bank. And the central bank is the one who says what happens on the network. For example, to bring it back to like a consumer-based approach, if I want to give somebody an apple in real life, I give them an apple and I no longer have the apple myself. If I want to do that with money digitally, then I need somebody to actually provide trust in between. Otherwise I can just say like, okay, I'll copy this money thing and I'll send it to 10 other people. And the result of that is that the money doesn't have value anymore. Therefore you need a central party to provide trust in a network. Now with blockchain, you remove the central party, you remove the need for that by providing everybody with a logbook that basically says what's the state of the network is, like who has which money or who has what data. And the way that it's secured is by providing it, by encrypting it, and also by storing it in a block-based system. Now, one of the most famous ones is Bitcoin, and Bitcoin is basically the most well-known blockchain network out there. The downside of it is that you can only use it for sending money back and forth. It's cool. It's the first version, basically, of like a new concept. It's the first implementation of Satoshi Nakamoto's paper on blockchain, but it's a bit limited in what you can do with it. Now, another example of what you can actually do with blockchain is, for example, flight insurance, decentralized insurance. So if you want to get insurance now, you need to go to an insurance company and they ask for a premium, etc. But you don't really need that in all forms of insurance. For example, when I was flying here and I wanted to insure myself, like let's say the flight is delayed and I want to make sure that if that happens, I get some money back, so my time is not wasted. So there's the guys from Ethereum who are working on that, and one of their first demos was a decentralized flight insurance, where you select your flight, you say which premium you want. In the current version, the current demo version, they've disabled the crypto versions, unfortunately. You put in some euros. For example, if I pay 25 euros, then depending on what happens, you can see the 45 plus means that if I have a delay longer than 45 minutes, I will get 120 euros. If it's cancelled, I get almost 200, and the same if it's diverted. Now the way this works is everybody with regular insurance as well puts in money to buy the insurance to sort of get some extra security, and then it's automatically paid out based on which flights have a delay. Now you can run this system automatically without anybody actually putting in manually information into the system. What they're using is, for example, Google Flights. So they get the information from Google Flights after the flight time has passed, which of the flights is delayed and which ones are not. It gets passed into the system automatically by Google, and based on that, the people in the system, in the insurance scheme, get paid out. Now, how does this work? First, you got transactions. Now, as you can see, there's 4 parties in this blockchain network, basically 4 nodes. And as you can see, each node has the same ledger, the same pages in the ledger. You can see that there's 3 transactions. The first transaction, A sends £5 to B. Then the second transaction, B sends £10 to C, and the third transaction, and so on. And all of these transactions get recorded in each node's ledger, making sure that you can't all of a sudden say like, no, but that B is sending the same £10 to A as well. Now, how you make sure that this is done is through, you put it into, you encrypt you sign your transactions. So if you go back, you see that B sends something to C. So what B does is he creates a transaction and he signs it with his private key. Now your private key is basically your password. It makes it possible to identify which node, which address send the transaction. Now your private key is, as the name implies, private. So you should never give it out, otherwise you have a problem and you might lose your funds. And your private key is coupled to your public key. And with your public key, people can verify that it's you who actually signed the transaction. So they can make sure, okay, it was this node that sent the transaction. Based on your public key, you have your address. So basically your account address in the top left, that's derived from your public key. I think it's the 20 most right bytes. And basically the account address is what you use within a blockchain network to send or receive funds or data, for example. So how this works is you have a block. All the transactions that are ready at the time that the block is created go into the block, depending on how big they are. Then a hash is included as well from the previous block header. So that's where the name comes from, blockchain, because you're literally chaining blocks together. The Merkle root will skip for now. And based on that, you get a chain of blocks with transactions in each one. Now, the hash you calculate based on the transactions of the previous block, all the transactions in there. But you have to, there are some requirements in which hashes get accepted. In order to make it secure, you want to make sure that somebody can't just add new blocks. So let's say, I don't like the way the system is set up. I don't like the way that I don't have much money, and I see that I lost my money when I sent €1,000 to a friend of mine in block number 1. And of course now the rest of the system continues. And I change my mind, I'm like, I kind of want my money back. So I decide to become a malevolent actor on the network. So what I do is I decide to change the block number 1. I make my own block, I say this is number 1 as well, and I send it out into the network. Now how do you protect yourself against somebody doing that? Is by making it very difficult for somebody to actually create the chain again. So what they did there is they did it with mining. So what mining is basically, mining is nodes have to solve a certain cryptographically difficult puzzle in order to find a certain solution. So we go back to the previous slide, you see the hash. So what they did in the Bitcoin and in the Ethereum network is that they said, okay, we want to get a certain hash, but we require the hash to have, let's say 10 or 20 zeros in front of it. Now for those who don't know, hashing basically always gives the same output when you put in the same input. So let's say you have a list of transactions, you hash them, you get basically a little string, that's your hash. Now you want to get a bunch of zeros in front of it. How do you do that? Because you can hash again, but you get the same output again. So what you do, you have to add some extra data and then see if it changes your output. The only problem is you can't predict what the output will be. That makes it cryptographically difficult. And that's what makes it cost a lot of time. So what miners do is they continuously use their computers, their computing power, to generate hashes, continuously trying adding different data to the transactions. So for example, it's called a nonce. A nonce you could see as just a number. So you could start with the nonce 1, then 2, then 3. You add it, you calculate the hash. Okay, it doesn't have 10 zeros in front. Great, we do it again. We add nonce number 2. We hash it, we see if it has 10 zeros in front. No, we do it again and again and again until finally you get the correct hash. And that person, that miner, can then say, okay, I solved the puzzle, I'm allowed to create the next block. Now, why would a miner do that? Because he's wasting a lot of computing power and energy, and therefore also money. Is because the miner that solves the puzzle gets a reward. Now, for example, in the Bitcoin network, it would be a bit of Bitcoin. In other blockchain networks, there's other basic rewards. Now, of course, you want to make sure that the reward is worth it. As you can see, the Bitcoin price went up, but also the difficulty in calculating the next block goes up and up and up, the longer the network is in the air. Now, it's not really ideal, because currently, off the top of my head, the Bitcoin network uses more energy per year than Chile. So that's quite a lot in the Czech Republic. So it's kind of bothersome that a single blockchain network is using so much energy. So you want to get some other ways of making the blockchain network secure and calculating the next block. So what you can do is you have different consensus algorithms. So the top one, the proof of work, is the one that's currently in Bitcoin, in the Bitcoin network and the Ethereum network, where basically nodes called miners solve a puzzle. What you can also do is use proof of stake. So instead of having miners, your nodes are called validators, and they have a certain assets. Let's say it's Ether or it's a bit of Bitcoin, and based on the amount of Bitcoin that they have, they put it into the system and they say, okay, I'm willing to stake this, and to make sure that I'm a truthful person. So I want to make sure that I'm the one who can create the next block. Now, based on how much asset or coins or Bitcoin you stake, you're more likely to be chosen to create the next block. Now, why does this work? Because a person that has a lot of stake in the system wants to make sure that the system works correctly. So if somebody puts in 100 Bitcoin, he's not going to say, no, I'm going to play around with the system, because then he basically loses his money. There's a chance for it. So the next one is proof of authority. So in case you don't want to put in your money, you can also say, okay, we're going to base it on reputation. For example, you know that certain people or certain nodes have a high reputation because they're trustworthy. For example, big organizations could run one of the nodes in the blockchain network. They're very trustworthy. Therefore, they're more likely to be picked in order to choose the next block. Yeah, this is a bit of a random slide. So all of this usually makes people go, yeah, this is awesome. I want to get a blockchain. And companies go, yeah, we've got this like new system that we want to design. We want to use a blockchain. And most of the time we have to tell them, yeah, no, you just don't need a blockchain. It sounds hip. Especially the past few years, this has been a real problem where people immediately go, can you please implement as a blockchain? And it's a waste of money, please don't do it. So there's very, very specific instances where you could actually use a blockchain. Most of the time, use a regular database. So, as I mentioned before, Bitcoin was pretty basic in what it can do. It's just sending money back and forth. And this guy in the bottom right is Vitalik. He's a very smart young Russian guy. I think he's 25 at the moment. And a couple of years ago, he decided, well, it's not really useful if we have to make a new blockchain platform for each use case that we want, for sending money, for insurance. So why can't we make a blockchain network where you can build applications on top of, like a generic blockchain network, and based on that, you can build applications from all sorts, from whatever you want. So that's when he wrote the paper on Ethereum, and the Ethereum network is now live. So how it works is you have the Ethereum virtual machine. It's a runtime environment for smart contracts. Now, what does this mean? Smart contracts are basically little pieces of code that live in a blockchain. For example, for the decentralized insurance example that I showed you, where you could send some money to that piece of code, you could deposit some money, and that code will run autonomously. So that code will get the inputs, for example, from Google, say, okay, this flight has been delayed. Therefore, I need to send this money that is in my smart contract. The smart contract can hold the virtual money itself. I need to send it to this list of addresses because these people are the ones, or these nodes are the ones that have their flight delayed. So the possibility, the use of smart contracts opens up a whole wide range of possibilities, which is really, really nice. They added gas to transactions, so there's a gas cost. Now, I've explained this before to people and they thought I literally meant gas from a car. So let me just specify, it's not literally gas, it's just a virtual money thing. Why they did it is so they don't have spammers on the network. So every action, every transaction that you do on the Ethereum network costs a certain amount of gas. Gas is linked to Ether. So for example, if I want to If I want to call the flight insurance and I want to insure myself, that costs me a certain amount of gas, which in turn costs me a certain amount of Ether, which in turn costs me a certain amount of US dollar based on the price of the Ether at the moment. So as you can see here, if I want to do a transaction, it can tell me like, okay, if I give a higher, if I do a transaction, I want the miners to actually include my transaction in the block, because the miners do a lot of work, so they also want to get a reward for it. And they don't really want to use my transaction, include my transaction in the block if they don't get any money for it or gas for it. So what I can do is I can set a higher gas price on my transaction and say, hey guys, I really need this to be done right now. So based on the price, they're more likely to include it in creating the next block. Or I can say, well, I need this done, I need to insure myself with the flights in a week, so I can just set a low gas price and eventually one of the miners will pick up the scraps and then my transaction will go through. Because gas is also linked to Ether, if the price of Ethereum goes up, the cryptocurrency Ether, the price of gas will also get more expensive. So therefore, if you do a transaction, it might be more expensive to do it. So for example, if you did for the same gas price, if nothing changed, if you did a transaction a couple of years ago, it would be hundreds of cents, and now it could almost be like two euros. So in order to sort of manage that, is you can also set the price between gas and Ether. They can sort of balance that in order to make sure that it doesn't get too expensive to do transactions in the network, otherwise nobody will use Ethereum. So earlier I mentioned smart contracts. This is basically a smart contract. It's very simple. It looks a little bit like JavaScript for the ones who know that. Luckily it's not exactly the same. It's quite a small, how do you say it, subset of a coding language. I'll get into the details later, but this is basically to set the price of diesel. So what is a smart contract? As I mentioned before, it's basically a self-executing contract. So you deploy it on the blockchain, it stays there. Whenever somebody calls one of the methods of the smart contract will update its internal state and give a response if necessary. Now it cannot be changed once it's deployed. So if you write some smart contract like this one, and you deploy it on the Ethereum blockchain, you cannot change it. So what you would need to do is if you deploy again, you'll create a new smart contract. Now the effect of that is let's say we go back to the decentralized insurance example. They have a smart contract for the decentralized insurance. People have deposited some money, but all of a sudden one of the developers notices, hey, hang on a second, there's a bit of an error in the code. What do we do? Well, we'll just deploy a new contract on the blockchain. Okay, but all the money is still in the old contract. We haven't updated the new one. So there's a few ways you can work around that. For one of them is, for example, that you split up the contracts, where you put all your logic in one contract and you refer to like a data storage contract in the other one. So in case your logic, there's a bug in that one, you can just replace the logic one and still point to the old one. So you don't have to, retrieve all your money from it again. So as I mentioned before, smart contracts are basically the same as user accounts. So they can also hold Ether as well, or any other cryptocurrency that they're good for. Now, as you can see, this was in the news for the past few years, that there's been quite a few bugs and hacks in the blockchain world, specifically with Ethereum with smart contracts, because it's very easy to make a little mistake in this. And if one of these contracts holds 100 Ethereum, 1,000 Ethereum, 10,000 Ethereum, and one of the people notices, hey, hang on a second, I notice there's a little mistake, and if I do this, I can get all the money from the contract. The money's gone then, that person has it, and you won't see it anymore, which is basically what happened in the past few years. So there's still some work to be done there, for it to be trusted by the general public. You don't want your insurance company to say, ha, funny thing, you remember that pension fund or that insurance fund? Yeah, all the money's gone. Some guy stole it, sorry. So in order to prevent that, there's a whole bunch of best practices that you can follow. These are known attacks, so you can check whether or not one of these things, one of these coding mistakes is in your code. There's also automated tools for this. There's standard libraries for doing standard things in your smart contract, which is really, really recommended to use. so you do not mess it up. Because it's much better to have like proven code than to try to design it for yourself. Don't do that. Use what's already written there and use what's like been proven.
So and there are also test environments to run this.
Yes.
To simulate the.
Yeah, there are people have made tools where they basically you can run the tool on your smart contract and they'll tell you like, okay, this is a mistake or this is a bug. Please don't do this. This is this attack factor. This is a short needed info bit. So let's say you want to get connected to the Ethereum blockchain. How would you do that? You need to download and use one of the Ethereum clients. And the most popular ones are Geth and Parity. With both of them, you can run a blockchain node. You can choose a full node or a light client. Now, the difference between that is if you run a full node, you have to synchronize the entire blockchain. So you basically get, remember that ledger I told you earlier about, with all the data and all the recorded transactions? Yeah, that's gotten pretty big. So it's up to 150 gigabytes since January this year. Which can be a bit of a pain if you want to sync that to your laptop, for example, because you might not have unlimited space. So what they also offer is light clients, where you only download basically the last few blocks. Like you download a subset of the state that you need in order to interact with the blockchain. And then occasionally your light client will interact with a full node for security purposes. This is really, really useful because on a mobile device, you're not going to download and synchronize the entire blockchain. Plus, it takes forever, and I don't think you want to tell a user, hey, you just press the button in your app, come back tomorrow when we synchronize the blockchain, then it works. So another option for actually connecting with the Ethereum blockchain is using MetaMask. And MetaMask is quite a useful browser extension. So what it does is basically passes your transactions that you do. So let's say you want to sign up for the insurance or send some Ether. You make a transaction for that, you sign it with your private key, and you pass it to MetaMask. And MetaMask passes it along to the Infura network. So what Infura is basically like a bunch of hosted Ethereum nodes. They've gotten quite big. So this is really, really useful because all you need to actually interact and use decentralized applications is just this one browser extension. You don't need to install a client, you don't have to synchronize the whole blockchain or a piece of it. You just install this Chrome extension and you can get to work and use, for example, the decentralized insurance, as I mentioned earlier. They also add some security to it, so they have some an identity vault, so you don't just have your private key out in the open. They encrypt it with a password and everything, so that's also nice. This is a slight, let's see, okay, Robson is still in there. Yeah, so you have different networks. So you have the main Ethereum network where everything happens, which is basically the official one. So if you want to buy some Ethereum that's actually worth money, it would happen on the mainnet. If you want to run your decentralized applications, you would do it on the mainnet. But of course, you also want to test stuff before it happens, so you don't accidentally deploy something that people will lose a lot of money from. So that's why there's the test nets. And there's quite a few. Currently, Robson is the main one. There's going to be a new version of Ethereum next year, early next year, hopefully. And then the Goerli one is basically will be the main one for that. But that's not really important for now. Unless you get into that, have a look at which test network you need to use, which one represents the best actual mainnet of the time. The local one, so if you're developing, you also want to run a local environment because it's a lot quicker than using a testnet on a mainnet. You don't have to wait, everything is instant. Let's say you're developing and you want to deploy it on the testnet to see if your application actually works, your smart contract works, and you want to try it out. Usually you need some Ethereum. Now on the mainnet you have to go to an exchange and use actual money to buy it. On, for example, Robson, the Robson testnet, you can go to one of the pages. If you Google Robson faucet, you basically get to this, you enter in your account address and they'll send you some Ethereum so you can play around with your development. I just want to mention this one. This is one of the most used JavaScript APIs for interacting with the Ethereum blockchain. And what this basically does is it gives you a very nice interface where you can code against in your development. So to make things easier, a guy a few years back came up with Truffle, and Truffle is a really, really great framework, a really great development framework. They've expanded it now it's the Truffle suite. So you can see they got Ganache, that's the top one. Basically this is Ganache. So Ganache is a really cool sort of blockchain explorer where you can see what's going on when you're developing for blockchain. So it gives you a few accounts to play with some Ethereum in it. You can see what transactions happen. You can see which block you're at. You can see what the smart contract contains in terms of code. So it's really, really cool, and it's quite easy to set up. You download it, you install it, and within 5 minutes you get it up and running. Drizzle, I'll quickly mention it, is basically a bunch of front-end libraries. So for example, for React, I think they're using Drizzle now also for other front-end libraries like Vue and Angular. So if you're building a front-end, try out Drizzle. It makes your code a bit simpler. And finally, Truffle. Truffle is the main thing. So what Truffle does for you is it provides you with a bunch of easy features that normally you have to code yourself, and it's just a difficult situation. So one of them is the smart contract lifecycle management. So as I mentioned earlier, once deployed, a smart contract can't be updated, but you still want to sort of manage it in an easier way. You don't want to write it down like, okay, what did I do with my smart contract and when? Truffle can take care of that for you. The same with testing, which is very, very important. I would say it's one of the most important things you should do if you get into blockchain development. You cannot skip tests. Normally, when you have another application, if you build like a little website, you can say, oh, okay, we'll skip the tests. If you work with smart contracts, don't do it. Even if it's a simple thing, just add the tests. It will save you a lot of headaches later on. Deployment as well, and network management. But I'll show you that in the demo. So installing it is basically this. If you got npm and node, all you have to do is run this command and you're done. It's installed. Once you run Truffle and you create a new Truffle project, you'll see these 4 folders. So the contracts, that's basically where the Solidity contracts are. So those are the smart contracts. And Solidity, I forgot to mention, that's basically what the programming language is called, which is most commonly used for most smart contracts. There's a few other programming languages. One of them is Viper, but they're not really used much. Migrations, as I mentioned, those files help you for deploying stuff to the blockchain. Tests is your tests, and of course you get your configuration file. So, as I mentioned earlier, the migrations, basically what migrations is every time you update your smart contract, or you deploy a new smart contract, you want to make sure that it's done in a way so you can reproduce it from the testnet, for example, to the mainnet. So that's where Truffle comes in with migrations, and this is the migrations smart contract. So how Truffle does this is they actually create a smart contract as well. They deploy this in the blockchain first. Then they check, okay, which migrations have you run? And you can see that here in last completed migration. That's where they check which of these migrations you've run last. And a migration is basically saying, okay, deploy this contract, then use the address of your deployed contract and pass it as an argument to the other contract that you want to deploy. Because sometimes when you want to link multiple smart contracts together, you need the address of one of the smart contracts as an input argument for the other smart contracts. Now Truffle makes this very easily and sort of handles the dirty details for that. So this is basically a little migration file. As you can see in the top, it has 2 smart contracts that is important, the storage one and the info manager. And what it's saying is it's first deploying the storage contract, it's waiting until it's deployed, and then it uses the address of the smart storage contract as an input to the info manager smart contract, and then it deploys that one as well. So for example, as I mentioned earlier, when you have those modular smart contracts where you put your data in one smart contract and your logic in the other, this would be the way to sort of handle that stuff as well. So I have a little demo. Let's see if it works. Let's see. Let me try to get the code up. Okay, so as you can see, we've got, what's in the big? Let's see. Now, this is a little demo project from the Truffle website, and it's basically about a pet shop where you can adopt some pets. So as you can see, we have a migrations folder, which is what we just discussed, where you have the initial migration to deploy the migration smart contract. And then whenever you want to deploy your contracts or deploy a new version of it, you would create another migrations contract. And the way you do that is you update the number in front of it, you create a new file. So if we want to create another one, it would be free, and then underscore with a human readable description of what the migration is about. For example, to fix a certain bug, or to do a new version of the contract because of this and that. But what's important is you always have to put the number in front of it, because that's what Truffle uses in order to check which migrations you've already run. So it only runs it once. Now in this case, you can see it's a very simple migrations file. Basically, it's about the adoption. Now, adoption is a smart contract, which you can see here. There we go. So what we can see here is you have a bunch of pets. There we go. And basically, if a person wants to adopt a pet, they call the function adopt pet with a pet ID, and then it's set as that. Message from sender is the address of the account that calls the function in the smart contract. So let me just show you the actual working way. Right. So we have the smart contract. Now we want to get it onto the blockchain. So what we do is we say Truffle compile. That will compile the smart contract. I've already done that, so it doesn't have anything to compile. That will compile this smart contract that you can see here, the .sol file, into a JSON file. And what the JSON file looks like is actually this. It's just basically all the functions in a JSON format with a bunch of extra information. Also, for example, where the smart contract will be deployed to, etc. All of this will be can be found here. You don't really need to do anything with this. Truffle uses that, or other frameworks use this to sort of interact with the blockchain for you on your behalf. Now, next we want to deploy the smart contract. So what we do then is we say Truffle migrate. Now I've already done it, so I'll run it with the reset flag. And what that does is basically it runs all the migrations again. So it will first deploy the migration smart contract, and then it will deploy the adoption smart contract based on these things here. Keep losing the mouse. So it will first run the first one, and then it will run the second one, and that'll be that. So if we see what happens, we can see this. Now as you can see here, it's basically run the first one, and then it replaced the existing migration smart contract that it already had on the blockchain, my local blockchain. You can see what the hash of the transaction was. Now this is quite useful. The transaction hashes you will use oftentimes to see, okay, what happened. So in this case, I'm running it locally, so I have like a little development environment to see, okay, what happened with my transactions. It's easy to see it. On the actual mainnet, you don't have that. So what you would do is you would go, for example, to Ethereum. Now Ethereum is a very useful website that basically, it's a blockchain explorer. So it keeps track of everything that happens on the Ethereum blockchain. So you can sort of take the transaction hash, not this one because I ran it locally, and then it will show you, hang on. I'll show this after the demo, that might be easier. You can basically see what happened within a transaction, like why did it fail, how much Ethereum did it use, how much gas, which addresses were involved in it. For example, you can see that this is the account that I used to create a transaction, to actually deploy the smart contract. Now if you see this one, it has the same the same account that we used. And you can see that my balance, so initially I had 99 Ether plus some more. And here you can see that it's going down because I'm using my actual Ether to pay for the gas to do the transactions. So now that the smart contracts are on the blockchain, we can use Ganesh, as I mentioned earlier, to see what's up with that. So you can see that I have a bunch of accounts with the relevant addresses that I can use to do transactions with. The mnemonic I'll skip. Now you've got the blocks. So basically I think Ganesh does 1 transaction per block. I'm not entirely sure. I should look that up. But basically, like, these are the different blocks that have been mined since I basically ran the migrations. So the only thing I've done so far is I've deployed both smart contracts to the blockchain. And here you can see that my actions have generated 4 blocks. And here you can see the transactions, which one will happen. Okay, let's try that again. Alright. So what I've done now is I have this is the pet shop. So this is basically the interface that's linked to the smart contract. So we can see here we have a few dogs. As we saw in the smart contracts, there are 15 of them. And all of these dogs we can adopt if we want. So if anybody has any preference, let me know. For example, let's adopt Leonore. What will happen if I do this is I press adopt. The function will be called in the smart contract to adopt this specific dog. If we go back to the code, you can see that this thing will be called. There's a check here with a required to see if it's actually a valid pet ID. So in case I want to mess around and I put in a pet ID of 100, while there's only 15 dogs, this will throw like a little error and it will basically stop the transaction. If it's correct, it will actually make me the adopted owner of the adopter of this specific pet. And let's try that.
So this would be an end user of your website?
Yes.
Adoption.
Yes.
He needs to log in and put his Ethereum account or something like that?
Yes. Ideally, you can sort of, in a way, abstract that based on what you want. But then there's a trade-off between how much do you want to stay into the decentralization part, or how much do you want to go more towards making it easier for the user. So what happened when I did that is actually MetaMask came up, because MetaMask, as we said before, is basically my interaction with the blockchain. In this case, I've set it to interact with my local blockchain. Now MetaMask is asking her, hey, I heard that this account, your account 1, wants to do a transaction to this address, which is the address of the smart contract. Look, if you want to do that, great. This will be a cost. You can either accept or deny that. And we can confirm it. And basically it worked, and we're now the proud owner of Leonore. We've adopted the dog. And if we go back to Ganesh, oh bloody hell. Normally, in Ganesh we could see that there is that the smart contract has been updated. Let's see if this works. Let's see if we can restart Ganesh. It's still remembered there. Let me quickly rerun it, see if it works. I will show you this after the demo if anybody's interested. And basically the smart contract has it now updated. The only problem is that, no, this actually might be the last interesting thing to show you. So what I did here was this. I can show you. Let me see what my mouse is. So I wanted to adopt this dog. So what happened was MetaMask gave me this notification as before, like, hey, you want to do this stuff, right? Do you accept? So I said, okay. Now it gave me an error. Now what happened here, and this might be a short last notification, is that MetaMask sometimes has a problem when you restart Ganache, but you don't restart MetaMask. So if you ever get started, this is really maybe not useful to anybody, but I just want to mention it anyway, is you have to go to MetaMask and you have to sort of reset your account. So you go here, you go to settings, you can see here below there's a setting, and there you can reset the account. So if you ever run into this problem, reset MetaMask account. If you Google on that, you'll find it. So that was basically it. If anybody has any questions.
So
Sorry, could you?
when you press adopt in the website,
Yes.
you are sending Ethereum funds to the person who wants the contract.
No, you're sending the funds to the smart. You're paying the funds to the network.
To the network.
Yeah. So you pay the funds in order to have the transactions done. So the funds will go to the miner who creates the block.
But this is when you
This is with any transaction. So it's with deployment, with calling functions and transactions, always.
funds always go to the network.
Yes. To the miners.
To the miner. And is it possible when a contract is running, it's not possible to cancel it?
Yeah, there are functions which is, I think it's called suicide, where you basically tell a contract to kill yourself, and the one who calls suicide one gets the funds from the contract. So a person who creates a smart contract could put this in to sort of make sure that we kill the contract, it's no longer living, and we get the funds back. Yeah. Okay, thank you very much for attending.